Is that okay? So you could probably take a guess that it's going to come in here, make a point. It's going to be a little point here. It's going to come down, hit, and then come back up. Now when it hits here, I think everybody's probably already realizing it's probably going to be walking concave down, because that's the only way to have that pretty little horizontal. Does everybody realize this is a relative maximum here? If it went up and then when it went down, does everybody see that has to be a relative maximum? What is zero? It is a relative minimum because it went down and then went back up. The chart answers lots of questions. Well, I think it's going to be concave down here and then leave concave down, but I've already shown you how if you don't take a second derivative, you might get some concavity wrong. You could probably take some good guesses here and be pretty close. How many of you have taken the second derivative? How many are you about to take the second derivative? And then what do you have to do with that second derivative? Set it equal to 0. So do that. Take the second derivative. I would take it from right here. I think it's easier. You have to set that equal to 0 and find your important numbers for your second derivative. Please tell all your friends that are in pre-calculus or they're in the other course if they don't know how to do negative exponents and all of this. They better take pre-calc over again in college. All right, all the negative exponents and all that good stuff. All the information you were supposed to bring to this course. That some of you did bring. Yes, sir.
How are you able to figure out what that positive number would be?
Which positive number? This one?
No, yeah, that one.
You set that 2 minus 2. Take the first derivative and set it equal to 0. But also realize if you put a 0 here, it doesn't equal 0. If you put a 0 here, it's undefined.
Okay.
Then put a 0 in the what? Denominator.
It's just whatever would equal 0. You put it into that equation.
Yeah.
Okay.
Critical numbers come from where the first derivative is either undefined or equal to 0. Now, a minute ago, you wanted to put 2 back in here to find the y value. You can't do that. This only tells you increasing, decreasing. All right? Y values only come from what? The original. The original only tells you y values. Now, did y'all find some critical numbers? Oh, Mr. Evans, don't use that word. Those are not critical numbers. They're extremely important, but they're not critical numbers. Dr. Butler would be very disappointed that I had to put my coffee down in order to write on the board. Okay, I'm going to factor out a negative 10/9. What power of x am I going to factor out? Negative 4/3. I can't convince them to always factor out. Oh, wow. So I find out the important numbers are negative 1 and 0. And you can put negative 1 back in the original and find out that you get negative, that's going to be negative, that's still going to be negative 1. That's going to be positive, so it's going to be 5, well, it'll be 6. Yeah, 6. Negative 1, 6 will be like up here high. Now, I want you to put numbers smaller than negative 1 in there, number between negative 1 and 0, and a number bigger than 0 in there, and tell me whether it's smiling, frowning, and write. I want you to actually start writing. Whether frowns are smiles, and frowns are smiles. See if you can figure that out by taking numbers and testing them right in here. Now, I will tell you the good news. See that 4 right there? You're raising any number to an even power. This number has got to be what number? It's gotta always be what? Positive. No matter what you put in there, that's gonna be positive. And then that negative times that, so this part over here is gonna always be negative. What you gotta know is what happens there, for like negative 10 or negative 20. That's a number smaller than negative 1. Somebody tell me if it frowns or smiles are smaller than negative 1. Smiles, okay, negative 3. That's going to become positive, so you get a negative times a positive times a negative. Yeah, you're right. It's going to do what? Smile. How about between negative 1 and 0? Test what? Negative 1/2. Okay, it's going to be a negative, positive, and a negative 1/2 is still going to make that a what? Positive. Okay, negative 1/2. Does everybody agree that negative 10/9 is never going to change?
Yes.
Does everybody agree that negative negative number here, when you raise it to the fourth power, has got to become positive? So I got, that's going to always be negative, that's going to always be positive. Now, I take my negative 1/2 and I put it right in here. What kind of number do I get? Negative times positive is a negative. So it does what? It frowns. Now, the scary part in your college classroom is the man just says smiles, frowns, and whatever. He doesn't actually take the time to show you these steps, because I'm a kind, caring soul, and I want you to look good compared to those kids from these other schools in college. I'm willing to show you. Okay, pick a number bigger than 0. Pick
1.
Okay, we agree if you put a 1 in there, it's going to still be a negative times a positive. And then that's going to be a what? Positive. So it's going to always what? Frown. Does that help? Explaining help? Yeah. And that's something you've just got to get fast at doing. And you don't want to try to work it out to an exact value. You just want to know whether it's positive or negative. Miss that wanted to take the day off. Are you okay with that idea? Just find out if it's positive or negative. Don't work it out to an exact value. A lot of students will spend all day wanting to get a negative 3/5. No, you just need to know it's what? Negative. Now, it's coming down smiling. And then right when it gets to negative 1/6, it's going to start what? Frowning. And it's going to come in straight down right there, frowning. And then it's going to leave there, frowning. It's going to go up and hit this one, and then it's going to come back down, still what? Frowning. And if you wanted to, you can find the x-intercept, which we really don't want to do, but there is one out there. You have a relative minimum at 0, and you have a relative maximum at what? 2. Relative minimum at 0, relative maximum at 2. Yes, ma'am?
How did you get the negative 1/6 again?
Okay, I took the negative 1 from my second derivative, and I
How
put
is
the
it
negative 1 back in. Where do I put the negative 1 in order to find a y value?
Oh, you put it back in the
Original.
Okay.
Y, right. Y values, okay. Y values come from the original.
So why?
Increasing, decreasing comes from the first derivative. Concavity comes from the second derivative.
So why did you choose to find that point?
Oh,
Because
because I
there's
knew negative 1 was probably an inflection. See how it went from smiling to frowning?
Yes.
So I went ahead and put that back in there so I would know what that value was.
Okay.
Yeah, I wanted to know, in other words, is it down here kind of low? Is it kind of high? Where does that occur?
Okay.
Plus, if I'm wanting to know the inflection point, that's the inflection.
How do you find the 6?
You plug it
Negative
in.
1 goes in the original.
The very
Okay,
first one?
right. I want everybody to flip to a blank sheet. Blank sheet at the top. And I want you to write. Y values come from the original. Y values come from the original. Then below that, critical numbers, increasing or decreasing, come from the first derivative, y prime. Now, y prime gives you critical numbers. You might want to put it in front. Y prime, like write y. Y equals gives you values of y. Y prime gives you critical numbers, which are only x values, and then it also tells you increasing or decreasing. Y double prime gives you important numbers, and it tells you all about concavity. So if you found a important number with your second derivative and you want to find the y value, what do you have to do? If you just wanted to know what is the increasing or decreasing value at a number, where would you have to go? Y prime. If I'm asking you about concavity, you go to the second derivative. If I tell you an x value and I just want to know the y value, where do you go? If you just want to find a y value, you go to the original. Yeah, put the word original down there somewhere. Y. For y values, you go to the original equation. For increasing, decreasing critical numbers, you go to the first derivative. For anything about concavity that you want to know, you go to where? Second derivative. If you find a really important number in concavity and you want to know its y value, where do you always go? You go back to the original. And it's not bad that y'all are having trouble with that. Every class that you ever teach has trouble with that. It's really strange. You'll have people that can get all the derivative chart and everything, but then they forget how to find the y value. Go to the what? Original. Okay, I am feeling pretty good. I have taught. You have hopefully learned.